Salam, peace be upon you. Let me begin with a scene so ordinary you almost miss how strange it is. You and I walk around a tree. Not halfway, not in a messy zigzag. We actually go all the way around, and we come back to the exact place we started. Your feet feel it before your mind names it. The air smells the same. The bark pattern lines up again. The world clicks into a clean kind of closure. And without being taught calculus, without being trained in topology, your mind does something mathematical with absolute confidence. It counts. One full circle. Not about one, not almost one. One. That instinct is older than education. It's built into how we recognize completion. A lap, a loop, a return, a cycle. A day that comes back to morning, a year that comes back to winter, a melody that returns to its home note, a story that comes back to its first scene, and suddenly the ending makes sense. In this part, we take that instinct and we weld it into the Pure Phi language with discipline so strict we cannot cheat. We are still inside PS0. We are still refusing to smuggle in spacetime, metrics, forces, particles, or anything with a familiar name. We are only allowed to speak with the alphabet we have earned. Phi from X to the circle S1, local lifts phi tilde, where lifting is lawful, A defined as d phi tilde, finite jets of phi, where the domain is typed, excised domains where derivative sentences live, and topological tokens like winding and holonomy. And now we reach a remarkable moment. We are going to watch discreteness be born inside continuity. Not because we insert a discrete knob, not because we assume quantization, but because closure forces it. Here is the core miracle in one sentence you can carry in your bones. When you complete a loop in a clean domain, the circle cannot help but count you back in whole turns. Now let's earn that sentence properly. Remember where we are coming from. We already built the clean domain, where derivative language is allowed to speak. We carved out D from a larger window W by excising the dangerous places, the defect neighborhoods, and the boundary colors. We did that so we would stop pretending calculus lives everywhere. Derivative words live where the lift is stable and the grammar does not tear. Then we fixed orientation conventions, because integers require a sign convention. You cannot meaningfully say +1 turn or -1 turn unless you declared what positive traversal means. That was part 17. Orientation is not a detail, it is the bookkeeper of sign. So now, in part 18, we finally do the thing that orientation and excision were preparing for. We take a closed loop. A loop is just a path that starts somewhere, travels, and then returns to the starting point. In our language, we name it gamma. Gamma is a closed curve sitting inside the clean domain D. And the question we ask is not mystical. It is as plain as walking around a tree. As you traverse gamma, what is the total change in the lifted phase phi tilde? Because phi tilde is a real valued lift of phi on the patch where the lift is valid. Phi itself is circle valued. Phi tilde is our local unwrapping, so calculus can speak. And A equals d phi tilde is the first derivative word we are allowed to use publicly. So along a path, the natural thing to do is integrate A along the path. We add up the little changes. For an open path from point P to point Q, the integral of A along that path is simply phi tilde at Q minus phi tilde at P, up to the usual lift ambiguity. That is ordinary calculus. But a closed path is special. For a closed path, P equals Q as a point in the domain. You return to the same place. And now the circle-valued nature of phi forces a rigid outcome. If you return to the same place, phi returns to the same circle value. But phi tilde is a lift. When you lift a circle to the line, returning to the same circle point does not necessarily return you to the same real number. You can return shifted by an integer multiple of a full turn. That full turn is 2 pi. So the only allowed difference between the beginning and the end of phi tilde on a closed loop is 2 pi times an integer. This is not a physical law we impose. It is the definition of what it means to be a lift of a circle-valued field. And this immediately gives our main equation, said in a way you can hear. For a closed loop gamma contained in D, the integral around gamma of d phi tilde equals 2 pi times an integer n. I'll say it again slowly, because this is the birth certificate of integers inside the continuous language. Integral around gamma of d phi tilde equals 2 pi times n, where n is an integer. That integer n is the winding number of phi around the loop gamma. It counts how many full circle turns the phase makes as you traverse the loop once. Now notice what just happened. We began with a continuous thing. Phi is continuous, circle-valued. Phi tilde, where it exists, is a smooth real-valued function. A equals d phi tilde is a smooth differential object on the domain where we are licensed. Everything so far is continuous. And yet, the moment we insist on closure, we are forced into integers. Not approximate, exact. Closure creates integers. Let me make this feel inevitable with a simple image. Imagine you paint a stripe around the pole. You place your brush at a mark. You paint around. You come back to the mark. If you come back and the stripe does not match itself, you have a problem. If you undershoot, there is a gap. If you overshoot, there is a doubled region. A perfect closure forces the paint to meet itself consistently. On a circle, meeting yourself consistently means the total angle you covered is an integer number of full turns. It is the same with phase. Phi lives on a circle. A full circle is 2 pi. Returning to the same circle point after a closed traversal means the lift can only differ by whole turns. 2 pi times an integer. That is why the integral becomes 2 pi n. It is the algebra of returning. Now I want you to feel the difference between two kinds of change. There is local change, which A describes. That is the derivative word. How phi tilde changes in small steps. Then there is global memory, which winding describes. Winding is not about the local size of A at one point. Winding is about what the field remembers when you complete the closed journey. This is why winding is a topological sentence. It cannot be erased by small smooth adjustments. It is not sensitive to the exact shape of the loop, if the loop stays in the clean domain and does not cross a real obstruction. It is a global token, a whole number memory. Now we must keep our discipline, because the universe is not obligated to give us integers everywhere. Integers are a reward for grammar being honored. So let's install the gates as living hygiene, the same way we always do, without turning this into an outline. First, the well-formedness gate. A winding claim is not a vibe. It is a typed sentence. If you want to assert the winding is n, you must have a loop that is actually closed. You must declare the loop gamma. You must declare that gamma lies entirely in the clean domain D, and you must declare an orientation convention for gamma, because reversing orientation flips the sign of the integral. If gamma is not closed, the sentence "how many times around" is not a sentence. It is like trying to count laps without crossing the finish line. It is like claiming a chapter ended when the last page is missing. And if gamma crosses outside D, the sentence is illegal in PS0, because outside D, the derivative token d phi tilde is not defined as a lawful word. You cannot integrate what you are not allowed to speak. So the first gate is simple. No closure, no integer claim. No clean domain, no winding token. No declared orientation, no signed count. Second, the invariance gate. The winding number must not depend on our descriptive choices. If we change the lift by adding 2 pi times an integer everywhere on the patch, phi tilde goes to phi tilde plus 2 pi k. That changes phi tilde, but it does not change d phi tilde, because the derivative of a constant is 0. Therefore, the integral of d phi tilde around the loop is unchanged. So winding is invariant under lift shifts. If we change charts on overlaps, the jet components change by chain rule, but the meaning must survive. Winding is not a coordinate spelling, it is the equivalence class result. As long as we are speaking the same phi and staying inside the lawful domain, the winding number cannot depend on whether we label the patch with xy or uv. The integral is a geometric statement about A along gamma, not about our coordinate preference. And if we deform the loop slightly, sliding it around like a rubber band on a table, as long as the deformation stays within D and does not cross a defect or a boundary or a declared obstruction, the winding cannot change continuously. Because it is an integer cannot drift by a small amount. It can only jump when the grammar breaks, when the loop crosses something it was not allowed to cross. This is why winding is so powerful. It is the opposite of fragile. It survives smooth deformation. It is the meaning that stays when the spelling changes. Third, the domain gate. This one is ruthless and it keeps us honest. Winding is undefined for loops that cross defects, boundaries, or illegal cut loci, unless you explicitly expand the sentence to account for those obstructions in the later defect grammar. In other words, you cannot draw a loop that cuts through the very place where lifting fails and then complain that the winding became strange. That is not discovery. That is mistyping. This is why we built excision. D is the clean stage where derivative language can perform without tearing. A loop used for winding is a loop on that stage. If your loop leaves the stage, you are no longer reading the play. You are backstage where the lighting rigs are exposed and the script is not meant to be spoken. So domain honesty is part of the meaning. A winding claim is not the winding is n, period. It is the winding of phi along the oriented closed loop gamma contained in D is n. Domain is not decoration. Domain is the sentence. Fourth, the non-encodability challenge. Suppose someone comes and says, I have discovered non-integer winding. I have discovered fractional winding. I have discovered a new primitive. In PS0, our response is not to argue loudly. Our response is to test their grammar. Are you sure your loop is closed in the sense of the field, not just in the sense of your sketch? Are you sure your start and endpoints agree in the same lift class? Are you sure you did not cross an excised neighborhood? Are you sure there isn't a hidden obstruction inside the loop? Are you sure you did not quietly change the domain without declaring it? Most fractional winding is a symptom of one of these failures. If after all of that they still insist, then the burden shifts. They must prove that their claim structure cannot be rewritten as a lawful PS0 statement about phi, its lift structure, and topology. They must show non-encodability. And in most cases, they will not be able to, because the circle is unforgiving. Closure plus cyclicity forces integers when the domain is clean. So the discipline is, do not promote a typing error into a new ontology. Now, before we go deeper, I want to keep the triunity alive in the most precise way we can, without smuggling in spacetime. Remember what triunity means here. It does not mean we have three separate fields floating around. It means that our one derivative word A equals d phi tilde has three inseparable readouts when we interpret it as cadence, texture, and transport, omega, kappa, nu. Always welded, always recomposing into A. Winding is not spatial topology only. It is not a story about space as a container. It is a story about phase memory under closure. And because omega kappa nu are readouts of the same A, you cannot change winding without changing the integrated behavior of A along the loop. That means you cannot secretly tweak cadence around the loop while keeping texture fixed in a way that preserves A. If A is fixed, the winding is fixed. So winding is a triunity statement in disguise. It is a statement about the whole A, and therefore about all three echoes together. The loop remembers the combined structure, not a single projection. Let me make this intuitive with a human scale analogy that does not add new primitives. Think of a melody returning home. A melody travels through notes and phrases, but it returns to its home note. The return is not only in pitch, it is in rhythm and phrasing and resolution. If you try to return in pitch while breaking the rhythm so completely that the piece no longer closes as a coherent musical loop, you have not truly returned. Closure is a joint constraint. In the same way, winding is not merely how the phase angle went around. It is how the entire derivative structure A behaves across a closed traversal. The closure is what forces the integer. Now let's go back to that equation and make it feel even more inevitable. Integral around gamma of d phi tilde equals 2 pi times n. Why is it 2 pi? Because the circle S1 is the space of angles modulo full turns. A full turn is 2 pi. On the circle, adding 2 pi does nothing. It returns you to the same point. Why is n an integer? Because you cannot return to the same circle point by adding half a full turn, unless you redefine what same means by moving to a different object. In the circle itself, the equivalence is modulo 2 pi. So the difference between two lifts representing the same circle value is always 2 pi times an integer. So the integer is not a measurement. It is a bookkeeping consequence of the object you chose, a circle valued phi. This is one of the most important themes in Holophase. The universe's discrete tokens are often forced by the grammar of the representation, not by sprinkling discreteness on top. Now let's spread this intuition across scales, but carefully, without drowning the listener. Start with the body. If you run on a track and complete a lap, the scoreboard counts 1. If you stop at the far end, you do not get half a lap as a completed unit. You can measure distance, yes, but the grammar of laps is about closure. A lap is a closed-loop event. Laps are integers. Move to a mechanical example. A gear rotates. One full rotation is one turn. You can stop at any angle, but the notion of completed turns is counted in integers. The moment you ask for completed cycles, you are in winding territory. Move to biology. DNA wraps around proteins. The details can stretch and squish, but the linking and winding constraints are integer-like in the topological sense. A molecule can wiggle continuously, but its winding class does not change unless you cut it or pass strands through each other, unless you cross an obstruction. That is exactly the domain gate story in molecular clothing. Move to the sky. The Earth returns to roughly the same position relative to the Sun after a year. But a deeper integer closure is the idea of orbital count. 1 orbit, 2 orbits, 10 orbits. The orbit count is a winding count of a closed cycle. The details of speed vary, but the completion is counted whole. And now the key point. All of these examples are not extra physics. They are demonstrations of the same logical structure. Completion is closure. Closure forces a count. And when the underlying object is cyclic, the count is forced to be integer. Now, because we are strict, we must also explain how winding can appear to misbehave. The most common reason is that the loop is not actually legal. Maybe it crosses an excised color near a boundary. That is an edge artifact. You are trying to count winding while your loop is scraping against a place where the language is not licensed. Maybe it passes too close to a defect, where lifting is not stable. Even if you do not step exactly on the defect, the neighborhood can corrupt the derivative speakability. That is why we excise neighborhoods, not just points. The epsilon buffer matters. Maybe you declare the branch cut for bookkeeping, and then you let your loop cross it without accounting for the cut discipline. Cuts are not physical walls, but they are part of how we track lifts. If you treat the cut casually, you will create apparent discontinuities that are artifacts of your bookkeeping, not of Phi. In all these cases, the right response is not to panic. The right response is to check the gates. Well-formedness, invariance, domain honesty, and non-encodability. Now let me sharpen the formal prediction and the formal falsifier in a purely grammatical way. Because in episode 13b, prediction and falsification are not about lab instruments. They are about whether the language can be kept consistent. The prediction is simple. If you are in a defect-free homotopy class inside the clean domain D, winding will cluster sharply to integers. It will not drift, it will not smear. It will land on whole numbers because the grammar forces it. If someone hands you a winding value that is persistently non-integer, the language tells you what to suspect first. The loop is not actually legal, the domain is not actually clean, the leaf discipline is not being respected, or a hidden obstruction is inside the loop. The falsifier is equally sharp. Exhibit a defect-free homotopy class in D, with lawful lifts and all equivalencies respected, where the integral around gamma of d phi tilde is stably not equal to 2 pi times an integer. Not approximately non-integer because of noise, not non-integer because we changed the loop across a defect. No, a stable non-integer value in a certified defect-free class while the loop is closed and the domain is clean and the lift is lawful. If such a thing existed, it would not just be a new effect. It would mean we misunderstood the grammar of circle-valued phase. It would mean either phi is not truly circle-valued as assumed, or closure is not what we thought, or the notion of defect-free class must be revised. In any case, it would be a deep failure of the language as we have sealed it. So winding is not a decorative topic. It is a coherence test of our entire PS0 construction. Now let me give you one more image that makes the whole thing stick. Imagine you are walking in a dark room with a string tied to your wrist and the other end tied to a post. You walk around and you return. When you turn on the light, you see the string has wrapped around the post. The string does not wrap half a wrap in a stable way unless you stopped and left the loop open, or you did something that is not a closed traversal. A closed traversal produces wraps that are counted in whole turns. 1 wrap, 2 wraps, 3 wraps. The string is the memory of closure. In our language, winding is the memory of closure stored not in a string, but in phi itself, through the integral of A around gamma. And now you can feel why this is the beginning of topology proper in our program. Because local derivatives tell you how things change in small steps, but topology tells you what cannot be changed by small steps. Winding is the first place where the language says, very calmly, this is not a matter of degree, this is a matter of kind. You cannot slide continuously from winding 1 to winding 2 without crossing something illegal. That something illegal is exactly what later parts will classify as defects, obstructions, charges, and holonomy. But we're not there yet. Here we only install the clean birth of the integer. Now let's tie this back to the long arc, so the listener feels why this matters. Episode 13a taught us the silent ground. Phi is the permission layer, not a substance. No absolutes, no containers, no teleology. Phi is irreducible. We cannot speak publicly without presupposing the capacity for distinction. Episode 13b is the language reveal. We froze the alphabet. We froze the grammar. We installed the discipline. No absolute phase, only invariance. No calculus without lifts. No derivatives without typing. No meaning without domain declaration. No coordinate worship. No new primitives unless non-encodability is proven. And now, in part 18, we see why this severe language is worth it. Because when the language is clean, it produces exactness. It produces integers. It produces a kind of certainty that does not come from measurement precision, but from logical structure. This is what I want you to carry as the deepest takeaway. In holophase, discreteness is not a rival to continuity. It is often continuity's shadow under closure and obstruction. When you close a loop in a circle-valued world, you do not get almost, you get n. Now I will seal the whole part in one final sentence that you can remember like a proverb, and then we will step toward the next gate of global grammar. A closed loop in the clean domain D forces the phase change integral to be 2 pi times an integer because cyclicity plus closure cannot produce anything else. And the natural bridge forward is this. If winding is a token attached to a single loop, we now need to understand how loop tokens behave when we compare loops, compose loops, deform loops, and classify loops as the same or different without crossing defects. Because the moment you have more than one loop, you need a grammar of loop relations. That leads us to the next part, the memory token that can be more general than an integer count. The way phi remembers itself as a U1 element around the loop, and the algebra of composing that memory. But for now, before we move, sit with this one clean equation, spoken as plainly as it can be spoken. Integral around the closed loop gamma in D of d phi tilde equals 2 pi times integer n. Closure creates integers, and that is the first whisper of the discrete inside the continuous, spoken without importing a single new primitive. Always, peace be upon you.